Dear students, welcome to the problem solving session on inverse Z transform using residue method. In the previous videos, we were solving problems on inverse Z transform using partial fraction method. Those who don't watch the partial fraction method, go to the playlist, watch the videos part 1 and part 2. In this video, we are going to learn how to find the inverse Z transform using residue method. Actually, it comes from CRT. Do you remember in semester 2, Cauchy residue theorem in complex analysis? We have learned it. The inverse Z transform, Z inverse of f of Z, we would have taken this as f of n. Now, Z inverse of f of Z is equal to the sum of the residues of small f of Z at its poles lies inside 3. Now, we have to know what is small f of Z. Small f of Z is nothing but Z power n minus 1 into capital F of Z, and C is the contour that includes all the poles of f of z. So in this video we are going to deal only the problems. I am not explaining all the theory. So we remember the poles are two types. When it is order 1, it is called as simple pole. For example, if it is z minus a whole power 1, then z equal to a is a simple pole. If suppose you have z minus a whole cube, then I will say z equal to a is a pole of order 3. It depends on the power. Now, if z equal to a is a simple pole, then how to find the residue? The formula for finding residue at the point z equal to a is simply limit z tends to a, z minus a into z power n minus 1 into capital F of z. If suppose the pole is of order m, where m greater than 1, then the formula is r of a 1 by m minus 1 factorial limit z tends to a d power m minus 1 divided by dz power m minus 1 z minus a whole power m into z power n minus 1 into f of z. So we have to simplify this first and we have to differentiate m minus 1 times, then finally we have to apply the limit. So this is the formula for pole of order m. Now let us go into the problem. You can see the typed version. So as usual, like partial fraction, here also I am taking 6 problems and I am going to solve first 3 problems and the remaining 3 problems is for your practice. Do you see the problem number 4 I solved in partial fraction method? That's why I took a new problem to solve in residual method. Let us solve 3 different kinds of problems using residual method. And according to me, residual method is the best method. Those who are very smart and lazy, they don't want to know any formula in Z transform or inverse Z transform. They can find the solution for the given Z inverse using Cauchy residue theorem, the residual method. If you know just the 2 formulas which I have mentioned here. Let us go into the problem. For residue method, we are going to follow just 4 steps. The first step is simplification. You have to simplify the problem which is needed in our format. Second step is finding the pole. Third step is finding the residues. And the final step is substitution. It is going to be very easy. First step, we know Z inverse of f of z is the given problem. In partial fraction method, do you remember f of z by z? I always used to bring in this format. If it is a partial fraction method, if it is a residual method, I have to find z power n minus 1 into f of z. Then the problem is going to be very easy. Now we know our f of z, that is z divided by z square plus 3z plus 2. Now I can split this into z plus 1 into z plus 2. Next, if I multiply with z power n minus 1 into f of z, we will be getting z power n divided by z plus 1 into z plus 2. Step 1 gets over. Now, step 2, we are going to find the poles. Equate the denominator to 0, then I can find 2 roots, that is z equal to minus 1, z equal to minus 2. See here, z plus 1 whole power 1. Similarly, z plus 2 whole power 1. So, z equal to minus 1 as well as z equal to minus 2, both are simple poles. So, we have to mention about the poles in step 2. In step 3, I am going to find the residue of minus 1 as well as the residue of minus 2. In step 4, sum of the residues will give the answer for this problem. Now step 3. I want to find the residue. Since minus 1 is the simple pole, I can write the formula for simple pole. R of A is equal to limit z tends to A, z minus A into z power n minus 1 into capital F of z. Here R of minus 1, therefore limit z tends to minus 1, z minus A means minus of minus plus z power n minus 1 into capital F of z. This thing we have already found in step 1. Therefore, limit z tends to minus 1, z plus 1, z power n divided by z plus 1 into z plus 2. Now, z plus 1, z plus 1 get cancelled. When I apply the limit, we will be getting minus 1 whole power n divided by minus 1 plus 2. Therefore, my answer is minus 1 whole power n. You can see the typed version. Next, similarly, I have to find residue of minus 2. This is also simple pole. So, I can write this as limit z tends to minus 2, z plus 2, z power n minus 1 into capital F of z. From step 1, I know this. Now, substituting this limit z tends to minus 2, z plus 2, z power n divided by z plus 1, z plus 2. Now, z plus 2, z plus 2 get cancelled. When you apply the limit, you'll be getting minus 2 whole power n minus 2 plus 1. So, my final answer is going to be minus of minus 2 whole power n. You can see the typed version. And step 4, substitution. So, z inverse of f of z, this is my given question, is equal to sum of the residues of z power n minus 1 into f of z. We have only two residues, r of minus 1, r of minus 2. Just substitute the value, that is minus 1 whole power n minus minus 2 whole power n. This is my final answer. Do you understand, students? Here I doesn't use a single Z transform formula. Just using the residual theory, I can get the answer immediately. And one thing we have to remember, you have to write all the answers in terms of whole power n. Suppose you are getting the answer like 2 power n plus 2, then you can write this as 2 power n into 2 square, that is 4 into 2 power n. But this is also okay, it's not incorrect. This will be more sharp. Okay, let us go into the second problem. See here, the denominator power is whole cube. When the denominator power is more or number of terms are more, residue theorem plays a vital role in finding the answer in a simple way. As usual, let us take the problem f of z and multiply with z power n minus 1. We will be getting z power n into z plus 1 divided by z minus 1 whole cube. Next, step 2, make the denominator 0 to find the poles. Here we have only one data. Therefore, z equal to 1 is a pole of order 3 because the power is 3. The power is not simply 1. So, z equal to 1 is a pole of order 3. So, now we have to use the corresponding formulae. Step 3, we have to find the residue. If residue of A is a pole of order m, then the formula is limit z tends to A 1 by m minus 1 factorial d power m minus 1 divided by dz power m minus 1 z minus A whole power m into z power n minus 1 capital F of z. So either you can write this first or this, both are correct. Now according to the problem, we have r of 1 is the pole of order 3. So limit z tends to 1, m is 3, so 3 minus 1 whole square. Here 3 minus 1 is 2, we have to differentiate twice. Here z minus 1 whole cube and z power n minus 1 f of z. This z power n minus 1 f of z we have found from step 1. Next, substitute the value of z power n minus 1 into f of z. We will be getting this. Now z minus 1 whole cube, z minus 1 whole cube get cancelled. 1 by 2 limit z tends to 1 d square by dz square. Now multiply this z power n into z plus 1 because if you keep as it is, then differentiation will be little tougher. We have to do UV rule. So So z power n into z is z power n plus 1 plus z power n. Now it is going to be very easy. Limit z tends to 1. If you differentiate once, z power n plus 1 differentiation is n plus 1 into z power n plus n into z power n minus 1. If we differentiate this again, we'll be getting limit z tends to 1 d n plus 1 into n z power n minus 1 plus n into n minus 1 z power n minus 2. Now substituting the limit 1 by 2, 1 power n minus 1, 1 power n minus 2. Whatever it is, 1 power anything is simply 1. So I don't want to worry about the problem. So I can simply write this as n into n plus 1 plus n into n minus 1. If I take this n outside, n plus 1 plus n minus 1. Now minus 1 plus 1 get cancelled. Therefore 1 by 2 n into 2n. 2 get cancelled. My final answer is n square. See the typed version. The answer is n square. So residue of 1, which is pole of order 3, is going to be n square. Now we have to write the final step. Z inverse of f of z is nothing but sum of the residues at the z power n minus 1 into f of z. According to our problem, we have only one pole, that is r of 1. Therefore, my answer is going to be n square. Problem 2 gets over. Now let us go into a problem which consists of the denominator with pole of order 1 as well as pole of order 2. Now multiply z power n minus 1 with f of z. We'll be getting z power n minus 1 into z cube divided by z minus 1 whole square z minus 2. This is going to be z power n plus 2 z minus 1 whole square into z minus 2. As I said, now if it is z power n plus 2, don't worry. At the end of the problem, by substituting the value, we can split this. Now we have to find the pole. Step 2. Make the denominator 0. We'll be getting z equal to 1 and z equal to 2 are the roots. Z equal to 2 is a simple pole because the power is 1. Z equal to 1 is a pole of order 2. So we have to apply two different formula for simple pole as well as pole of order 2. First, we found residue of 1, pole of order 2. The general formula R of A is 1 by m minus 1 factorial limit z tends to a d power m minus 1 divided by dz power m minus 1 z minus a whole power m z power n minus 1 into f of z. Now we are going to substitute the value r of 1 at the pole of order 2. So 1 by 2 minus 1 factorial, that is 1 factorial, limit z tends to 1. D power m minus 1 means m is 2, 2 minus 1 is 1, z minus 1 whole square into z power n minus 1 f of z. Now substituting the value of z power n minus 1 into f of z, will be getting limit z tends to 1 d by dz of z minus 1 whole square z power n plus 2 divided by z minus 1 whole square into z minus 2. Now this z minus 1 whole square and z minus 1 whole square get cancelled. You can see the typed version. Now we have to use the formula u by v rule. Denominator is v square, numerator is v du minus u dv. Just you can see a simple differentiation. Denominator is z minus 2 whole square, then numerator is z minus 2. Differentiation of z power n plus 2 is n plus 2 z power n plus 1. One power is getting reduced. Minus, if I keep z power n plus 2, z minus 2 differentiation is 1. Now let us apply the limits inside the data. When I apply the limit, we know that 1 power n plus 1 or 1 power n plus 2, it doesn't matter. Both are going to be 1. So I will be getting n plus 2. 1 minus 2 is minus 1 and here minus 1. So minus n minus 2 minus 1. I can write the final answer as minus of n plus 3. Now we have to find the residue at 2. It is a simple pole. So R of A is going to be limit z tends to a, z minus a into z power n minus 1 into capital F of z. Now substituting the value of z power n minus 1 into capital F of z from step 1, we get this. Z minus 2 get cancelled. Applying the limit, we will have 2 power n plus 2 divided by 2 minus 1 whole square. So the answer is 2 power n plus 2. As I said in the problem 1, either you can keep 2 power n plus 2 as it is, or simply write this as 2 power n into 2 square, that is 4 into 2 power n. Both are correct. This is more accurate. My final answer is going to be sum of the residues of z power n minus 1 into f of z. That is simply r of 1 plus r of 2. R of 1 is minus of n plus 3 plus r of 2 is 2 power n plus 2. So either you can write like this, or you can write more preciously minus of n plus 3 plus 4 into 2 power n. You see students, none of the problems I didn't apply any Z inverse formula. I am getting the answer using just the two formula, that is pole of order m or pole of order 1. That is the power of residual theory. So whatever the method you like, you can solve. Either you go by partial fraction, or you go by residual method, or you go by long division method, or you go by convolution method. Whatever it is convenient for you, you can follow, unless otherwise nothing is mentioned. If they give simply solve, then you can apply any method. If they mention solve by residual method, then you have to do by a specific method. Otherwise, you lose all your marks. So just have a look on the question, understand whether it is a specific method or it is a general question, answer accordingly.
Thanks for watching. Subscribe to our channel and share to your friends. See you in the next video. Bye bye.